quick follow-up to the last video, proving a trig identity part 2. Just going to do this one as quickly as possible. A couple people asked me this question, so let's take a quick look at it. Here, remember that we're going to transform the left-hand side into the right-hand side without changing the right-hand side, right? And also, please remember that the only way that we can actually do this is to be very familiar with our fundamental trig identities. There are three different categories of them: the reciprocal identities, the tangent and cotan identities, and the last one is the Pythagorean identities. Altogether, there should be 8 of those identities. I did them on another video, so if that's bothering you, confusing you, please let me know. Can we look at this for just a second? Just something to think about. I'm not going to transform these, but let's look at this for a second. Okay. What I'm wondering is this. Cosine over sine. Cosine over sine is cotan, isn't it? Now my question is tan theta over sine theta equal to secant theta? I have to admit to you, I'm not sure. But I'm going to try this. So what I'm wondering is this plus sine this one? So I actually have not done this problem, but let me just break this out. And the way that I'm doing this is just this. Look, if we have 1 plus 2 over 4, we could rewrite that as 1 over 4 plus 2 over 4. And I'm using this as my argument for what I'm about to do here. So I'm going to take this tan over sine. So tan theta over sine theta. And I'm saying that that is this, right? And then I'm going to take this cosine over this sine, so cosine theta over sine theta, right? Because if I was going to add them, they have common denominators. I wouldn't add the denominators, would I? I would just add this. I'd have tan plus cosine and tan plus cosine, okay? So what I'm hoping is that this is this. So here's my plus cotan theta, and I'm going to draw the whole thing in there, but I just want you to know that I believe that this is, well, I know that this is true, but I'm hoping that's the right one. And this is secant theta. So what I'm hoping like crazy is that this over here goes to secant theta. So this is what I'm going to do here. I'm going to work just on this piece. Remember, we're transforming the left-hand side into the right-hand side, so we're not doing any work on the right-hand side. We're only adjusting the left-hand side and trying to write it in different language. So I'm going to take my tan theta. So I'm going to take my tan theta, this tan theta right here. And I'm going to say that tan theta is the same as sine theta over cosine theta, and that comes from our cotan and tan identities, which are our come from our fundamental identities. And this solid, this refraction bar, is this one right here, and this sine theta is this sine theta right here. And just to kind of try to keep my pieces together, this is the cosine theta over the sine theta here. And most people don't rewrite all this crap, but I just want you to see that I'm staying consistent, that I have not adjusted anything on the right-hand side, and that the stuff on the left-hand side, I'm done with this. So look at this for a second, if you don't mind. This is sine theta over cosine theta over sine theta over 1. And this is what I know about this piece right here is a complex fraction, and complex fractions come in the form AB over CD, and they're solved by taking the numerator times the reciprocal of the denominator. So I'm going to do that. I'm going to take my sine theta over cosine theta times 1 over sine theta, right? I took the reciprocal of this, right? And look what happens here. Look what happens here. Oh, let me just be consistent. Cosine theta plus sine theta equals secant theta plus cotan theta. If you're wondering if you should write all this crap out, no. The right-hand side, you don't have to keep bringing it along. I just want you to know that we're ending up where we said we were going to end up, so I have to go back. So check this out. We can cross-cancel a cross multiplication, right? So we get 1 over cosine theta plus cosine theta over sine theta is equal to secant theta plus cotan theta. This one is proven, right? This one is, right? This one is that one, and we did that by cotangent ID. That's right. That's one of our fundamental identities. And this one, right? This and this are the same thing, and I prove that by using our reciprocal identities, reciprocal IDs. All right. I hope that was helpful. Look, I can't tell you enough. I can't make the argument to you clearly enough that if you memorize your fundamental identities, if you have them next to you, then everything is possible. Without it, it's just nuts, and I don't know how it can be done by anybody. So hopefully you have those fundamental identities memorized, and also the more you work on this, the more the pieces come together in your mind. So good luck.